Samsung plasma, model number PS42A451 P1, dead. When you plug it in, you might get a brief flicker of a red light from the standby light, and let's just zoom in on it. And we have no control. It's totally dead. I'm going to put on his face now and take the back off and have a visual inspection of the power supply, looking for any obvious signs of damage, bulging capacitors, etc. Back is off, and I've been looking at this power supply, and I can see a capacitor here. Let's see, can I zoom in a little bit? This capacitor here is bulging, and this is the smoothing capacitor for this standby power supply, this always 5-volt supply. This diode here rectifies it, and then this smooths that supply. I've hooked up my oscilloscope to this rectifier diode here on the catalog, and that hooked up the other lead to the ground. And what I'm going to do is have a look at my scope and see what's happening with this standby power supply. I'm looking at my oscilloscope now, and what we have here is 1 volt per division. That's a 0 volt line where it's set right now at the moment, and it's set to DC, and it's at a 2 millisecond time base. I'm going to plug it in now. Went up to 5 volts and then it came back down, shut down. I'm going to remove that capacitor now and replace it and see what happens. I'm going to remove this capacitor now. It's circuit reference number CB402. It's a 2200 UF 10 volt high temperature capacitor, and a bit of fresh solder on it, help it on its way. Removing the solder. I'm going to clean it off now with some alcohol, get rid of the flux, and I'm going to put this capacitor in. It's a polarized capacitor, electrolytic, which means it only goes in one way. You put it in backwards, it will explode on you. There's the negative markings on the capacitor. That goes to the negative side of the power supply, and you can get that in the shot, and you see this white spot, it goes to that white marking there. Negative goes there. The lead, get a final clean off, some alcohol. and get a cloth and dab it dry. I'm going to put the power supply back in the unit now. I have the power supply back in the plasma unit, and I've got my oscilloscope hooked up to the cathode of the standby 5V supply diode, and I have this lead connected to ground, and I'm going to plug it in and let you see the oscilloscope. And I can hear a relay clicking, that's a good sign. And as you can see, the power supply is staying up stable. And we're set at 1V per division. 1, 2, 3, 4, 5, just a little bit over 5V. It's a little bit of hash in the line, but it's not to worry about. What I'm going to do with it now is I'm going to upright the screen so we can have a look at the picture. But I can see activity on the control board. The lights are flashing. Let me see, can we get a shot behind this cable? You see the light flashing there beside that connector, so that means my control logic board is active. Just going to plug in the unit now and see what happens. Relay clicking. Standby light flashing, and we have a picture, it's up and working. The 5V supply on most units is constant, it's there all the time. It's not switched, it's what controls the microprocessor, and that should be there at switch on. It should never be switched off by itself. And I was expecting to see on the oscilloscope a bit of ripple pulses on it. That's what you would get with an open circuit capacitor, but that bulging capacitor must be somehow or another loading down the power supply, and it's shutting it down. And as you've seen with the oscilloscope, it will go up to 5V and then shut right down. When I replaced the capacitor, it stayed at a constant 5V. Mind you, I didn't get much time to measure it because it shut down so quick. I hope that's of some help out there somewhere, and thanks for watching.